All right, we are given this function and we need to find the oblique, asymptote, and hence sketch it. So first I'll give an overview of what asymptotes are, and then we'll kind of pick apart what we know from this function or what we can deduce from this function in terms of x-intercepts and etc. And then we'll start working on oblique asymptotes. So when you think about an asymptote, that's when a function is undefined. So say we have a graph of the asymptote is when the function here, so say let's say we increase values of x. So say we do x equals 1,000,000,000 or something like that. It will never cross this line or this asymptote, because at x equals 1,000,000,000, or pretty much it's just undefined. Even if you get really, really close to it in terms of y values, you just never get to that intercept. And in terms of functions, we can think of it, so this is not going to be the map of this function, but if we have 1 over 1 minus x, when this is undefined is when x equals 1. And so from this, we can determine that, for example, this vertical asymptote will be at 1, because when we try and look at the graph, it never crosses x equals 1, and it just doesn't exist, because 1 over 1 minus 1 is 0, and you can't divide anything by 0, so obviously the function will then be undefined. It just doesn't exist. So that's pretty much an overview of those types of asymptotes. And then if we look at asymptotes where we have a quadratic over binomial, we get kind of two lines similar to this graph up here of a rational function. We can get like a line that looks like, I'm going to try my best to draw these, they're not going to be super accurate. We can get a line like that where the vertical asymptote's like there, and then we get a different type of asymptote here. Again, horribly drawn. Do not use this in your exams. Or we can get another line that goes like so and so. So I should probably draw this closer and this one closer. And so what we get here is we get our regular, say this is x equals -1, vertical asymptote. So that's when the function's undefined in any case. Or, well, not in any case, but when the function's undefined is when x is set to -1. And we get what's called an oblique asymptote, which is this diagonal line. So let's say that's like y equals 2x plus 1. Again, not accurate at all, but an oblique asymptote would be in the form ax plus b. And so this is, again, when the function's undefined, when it's not able to pass this line, essentially. So if we think about it in this context, we'll start kind of working through this specific problem. So if we look at, for example, the vertical asymptote, when is this undefined? Well, it's undefined when x is -2, because -2 plus 2 is 0, and when you try and divide anything by 0, you get, no matter what, you get an undefined error on your calculator. So vertical asymptote is at x equals -2. Let's make this smaller and move it out of the way. Okay, so we have the vertical asymptote. Now we need to look at the intercepts, because that's the next easiest thing we can get. So y-intercept is when you set all of x to be 0, so any x you see to be 0. So if we do that, we just get -9/2. So it would be at 0, -9/2. Because remember, the x-intercept is just when, or the y-intercept is just when x is 0. So that's wherever it is on the y-intercept. The x-intercept. So the x-intercept, I won't explain why this is. I'll explain in a different video though. But the x-intercept is when you set this top quadratic to 0. So again, it's where you just find those solutions. So x-intercept, if we set this quadratic equal to 0, we can factorize and get 2x minus 3x plus 3. And then from that, we could just deduce x is, well, not 2/3, 3/2, or x equals -3. And so our x-intercepts are 3/2, 0, or -3, 0. So I'll just highlight these in purple so we know what we know about the graph so far. All right, so we have those pieces of information, but this is not enough to, for example, get that oblique asymptote. So what we have to do now is, I won't explain why this exactly works. Again, it's going to be in a different video, but what we want to do is get this form, where is it? X plus 2, right? We want to transform it into the ax plus b plus c over x plus 2. We just move this denominator to this side. And you can see again, we get that linear equation of ax plus b. And so what I do, and this works in my head, you can do different methods like polynomial long division, etc. But what I like to do is equate coefficients. So this just involves some simple algebraic manipulation. So what I'll do first is multiply everything by x plus 2, so we can get out the denominator here. Just multiply it here, and again, get out the denominator here. So we get 2x squared plus 3x minus 9 equals ax plus b x plus 2 plus c. And if we expand that out, we get ax squared plus 2ax plus b x plus 2b plus c. And then we want to group the like terms. So ax squared plus 2a plus b x plus 2b plus c. And so if we want to equate coefficients, we see that 2x squared, so that means a is equal to 2. So that's just 2x squared, same thing. And so now whenever we see a, we want to set it equal to 2. So we see a is 2 here, or we see an a here, so we do 2 times 2 plus b. And we will know that this x coefficient here should be equal to 3. So we'll quickly set that equal to 3. And then we'll just solve, and simple solving, again, b equals -1. And then now what we want to do is we have b, and we need to find c. So we take this here, 2 times -1 plus c equals, and so that's just a constant term, and so the constant here is -9, so equals -9. And some simple manipulation, c equals -7. So I'll color this so that you guys know what is what. So this stuff here is for B, and this stuff here is for C. And then A is just the coefficients that we already know. And so if we just put all these values into this bit over here, we get 2x squared plus 3x minus 9x plus 2, and then equals A is 2, so 2x plus B, well, B is minus 1, so minus 1 plus, again, minus 7 over x plus 2. And from that, we can start looking at graphing everything that we have. So if we go ahead and get that oblique function, we can start graphing this. So we know that again, this is a really bad drawing, so do not do this in your exam, but we get, say that's like 2x minus 1. We'll color that purple. And then we have if we go back up here, we have that vertical asymptote of at x equals -2, again, because that makes the function undefined. So if we do, I don't know, let's see, that's -2. We can do x equals -2 here. Just change that to red. And then finally, we can start plotting the x-intercepts, etc. Again, this graph is completely out of proportions, so it's not going to be correct at all. However, just bear with me. So we get x-intercept is -3 or 3 over 2. So let's say like -3 is here. And then 3 over 2 is like around here. So we have those, and we know the y-intercept because we set everything to 0, and that's at -9 over 2. So that's like maybe around here. And when you make these graphs, you might kind of wonder how you know which side, if it's either going to be this kind of outside bit or the inside bit. Well, here it's only physically possible to have it on the outside because you have your intercepts of the function on the outside. So it would look something like that and like that. Again, really bad drawings. Do not try and make it at least a little bit to scale. But what you can do in exams is just note down the different intercepts you have. So -2, half is here. And so that's pretty much how you graph these functions. So again, reiteration, when you get a function like this and you have to sketch it, first find the vertical asymptote. That's when the denominator is equal to 0, because you can't divide by 0, because that would be an undefined. Then you get the y-intercept, set all the x's to 0, that will get you the y-intercept. X-intercept, set the numerator to 0, and you should get 2 values. Sometimes you won't. That's based on the discriminant. So if you in those cases, you want to make sure you know that you're drawing the correct graph in the correct way. And then if you want to get the oblique asymptote, you want to set it to ax plus b plus c over whatever the denominator is. So it's x plus 2. And then you just equate coefficients. You can do it using polynomial division to get the oblique function, and then plot the vertical asymptote, plot all of your intersections that you found, and yeah, that should be it in terms of graphing these types of functions. See you later.